Hello everyone. We have one more important question in electric current chapter 9, that is derive the expression for R is equal to resistivity into length of the conductor divided by cross sectional area of the conductor. Most of the times in exam paper we are getting this question for 2 marks. So as we all know that resistance of the conductor is directly proportional. Resistance of the conductor means wire resistance of the conductor is directly proportional, means equals to length of the conductor. This is the first point you have to remember when deriving the expression for R is equal to resistivity into L by A. Resistance of the conductor is directly proportional to length of the conductor. So we can write mathematical expression R is directly proportional to L. This represents resistance of the conductor is directly proportional to length of the conductor. Here we have a condition that this resistance of the conductor is directly proportional to length at constant temperature and length. Why they mention constant temperature? If temperature increases means in electrical poles or in some other places also we can see that there is an increase in the length of the wires. So that is why we mention at particular temperature, that means at constant temperature only the resistance of the conductor is directly proportional to length of the conductor, and we consider this as equation number 1. And another point we should remember is the resistance of the conductor is inversely proportional to cross-sectional area of conductor. So mathematically it can be written as resistance of the conductor is inversely proportional to means we should represent the term physical quantity area in the denominator, and we consider this expression as 2. These are the main 2 points everyone should remember. When the resistance of the conductor is directly proportional to length, R is directly proportional to L, and you consider this as equation number 1. And resistance of the conductor is inversely proportional to cross-sectional area of the conductor, and you consider this as expression number 2. And by using this expression 1 and 2, finally we get the equation. From equation 1 and 2. From equation 1 and 2 we get equation 1 is nothing but R is directly proportional to L. This is equation 1, and equation number 2 is R is directly proportional to 1 by A. If we observe this equation 1 and 2, resistance is a common. So resistance is proportional to constant. Resistance is directly proportional to L and inversely proportional to area. By removing this proportionality constant symbol, we are going to take equals to symbol. Instead of that, we are using one proportionality constant, that is resistivity. So in this way we got the expression from equation 1 and 2 that R is equals to resistivity, product of resistivity and length by area. Sometimes in examination they are asking what is the unit for resistivity. Already you know the unit for resistance. Resistance unit is ohms. Resistance unit is ohms. Area unit is meter square. Length unit is meters. By using these three, we can easily derive unit for resistivity. So by doing cross multiplication from this expression, rho into L, rho L into 1. Rho L into 1 is nothing but rho L, R into A, RA. So resistivity is equal to R into A. Here L is multiplying resistivity. If we send this sign means it will divide. So resistance, what is the resistance unit? Ohms. And area unit is meter square. And length unit is meters. So resistance into meter square can be written as meter into meter. Length unit is meter. Meter, meter get cancelled. Meter, meter get cancelled. And finally what we have? Ohm meter. So in that way we will get the SI unit for resistivity is ohm meter. This is very important unit also. For resistance simply ohms, and for resistivity it is ohm meter. This resistivity sometimes also called specific resistance. Resistivity is sometimes called specific resistance, and we have one more term, that is conductance. Symbol is sigma. So conductance is nothing but very simple definition. The reciprocal of resistivity is called conductance. The reciprocal of resistivity is called conductance. So no need to write this. While answering this question, derive R is equal to rho into L by A and unit. Specifically they ask the unit for resistivity, and about conductance you should mention. Okay. So in this way it is useful for one more question, like when they ask the unit for resistivity, means next conductance definition. After writing definition you can mention mathematical expression also. Definition is nothing but the reciprocal of resistivity is called conductance.